Assalamualaikum warahmatullahi wabarakatuh. Today we are going to learn new techniques of integration, which is the partial fraction. Okay, let's look at the learning outcome for this topic. Okay, by the end of this section, students should be able to integrate the rational functions by first decomposing the integrand as a sum of partial fraction. Okay, we use the partial fraction. Okay, next we look at what is the partial fraction. When we want to integrate the rational function such as 3 plus x over x times x plus 2, we decompose it into a sum of two partial fractions. It is an easy method to add two sum fractions such as 2 over x minus 1 plus 1 over x plus 2. But how do we break up 3 plus x over x plus 2 into a sum of these two different fractions? How do we break up it into these two different simple fractions? Okay, we first need to understand the concept of proper and improper fractions. Okay, let's look at the rational function. Okay, what is the difference of proper and improper fraction? Suppose a rational function is given by px over qx, where p is the numerator and qx is the denominator. Qx is denominator. Okay, if the degree of px less than the degree of qx, means the degree of numerator less than degree of denominator, then the rational function is a proper fraction. However, if the degree of px is greater than or equal to the degree of qx, then the rational function is an improper fraction. Okay, in this case, we need to do a long division first. We have studied the long division in previous chapter. Okay, let's look at the example of proper fraction, improper fraction, and the details of proper and improper fractions. So look at the first example. Okay, the degree of numerator is 1 and the degree of denominator is equal to 2. So it is the proper fraction because the degree of numerator is less than the degree of denominator. For the second example, we look at the degree of numerator is 2 is equal to the degree of denominator is also 2. Therefore, the second example is the improper fraction. And the third one is, okay, we look at the degree of numerator is equal to 3 and the degree of denominator is equal to 2. So, it is the improper fraction since the degree of numerator is greater than the degree of denominator. Okay, let's look at the partial fraction. Okay, there are 4 rules we must follow when doing the partial fraction decomposition. First, we look at the rules number 1. Rules number 1 mention that the numerator must be at least 1 degree less than the denominator. 1 degree less than the denominator. For example, it must be a proper fraction. Otherwise, we divide it using long division. Okay, let's look at this example. The integration of x cubed plus x over x minus 1. We integrate with respect to the x. Since the degree of numerator is equal to 3, is greater than the degree of denominator equal to 1, so it is improper fraction. So we have to do a long division. Okay, we have learned before how to do the long division. So let's look at how to do this long division. So x cubed plus x, okay, we divide by x minus 1. Okay, let's look at this x cubed. So x cubed divided by x is equal to x squared. So then x squared we multiply with x minus 1. So we get x cubed minus x squared. Then we take the difference between these two. So we cancel out x cubed. And then this x squared, x squared plus x minus x squared. So means x plus x squared plus x. Then we refer this x squared divided by x, we get plus x. So x times x minus 1, we get x squared minus x. Then we take a difference between these two. So we cancel out this one, x squared minus x squared, and then x minus negative x. So we get plus 2x. Then we divide x squared, 2x divided by x. So we get plus 2. And then 2 multiple with x minus 1. So we get 2x minus 2. Then we take a difference between these, 0, and then 0 minus negative 2 is equal to plus 2. So we have the new form of this improper fraction. So we have x squared plus x plus 2 plus 2 over x minus 1. And then we can simply integrate this fraction. That one. So we can simply integrate this. Okay, let's look at rule number 2. Okay, every linear factor ax plus b in the denominator correspond to a partial fraction of the form a over ax plus b, where a is a constant. For example, we have this proper fraction 2 over x squared plus 2x plus 2. We integrate with respect to the x. Okay, this is a proper fraction since the degree of numerator is less than the degree of denominator. So we don't need to do a long division. Okay, then the first step, we have to factorize the denominator. We look at the denominator. Okay, we first factorize the denominator. Okay, we factorize into 2 over x plus 2 times x plus 1. We factorize this one. So we get x plus 2 multiple with x plus 1. And then the second step, 2 linear factor in the denominator means 2 partial fraction. We have the 2 linear factor in the denominator. So we separate the denominator with 2 partial fraction. Then we get this one, a over x plus 1, a over x plus 2, which is the first denominator, x plus 2, and the second one plus b over x plus 1 divided by the second denominator. First denominator and the second denominator. Then we add the partial fraction. This partial fraction, we add the partial fraction. So equal to the, we equate the numerator. This expression are equal the original equation. So we equal with the new partial fraction, the 1 plus 2. And then we equate these two partial fraction with the original fraction. You do the cross multiplication. This one, we do the cross multiplication. So we get a times x plus 1 and b times x plus 2 over x plus 2 times x plus 1. This one. And then we equate this numerator part with this one. So 2 equal to a times x plus 1 plus b times x plus 2. Then we want to solve the value for a and b. Okay, let's say we look at this denominator part. Okay, when x equal to negative 2 and x equal to negative 1. Negative 1. Okay, let's say when x equal to negative 1, we substitute into this equation. So we get 2 equal to, okay, this is 0 plus, okay, we substitute x equal to negative 1 into this. So we get b times 1. So b equal to 2. Okay, then when we let x equal to negative 2, this one, x equal to negative 2. So 2 equal to, we substitute into this function. So a times negative 2 plus 1 is negative 1. Okay, plus b times 0. So we get a equal to negative 2. Then we can write out our partial fraction. Okay, we substitute the value of b and a into this function or this partial fraction. So we get negative 2 over x plus 2 plus 2 over x plus 1. Okay, then we can simply integrate these two partial fraction separately. So this one we use the u substitution, then it equal to negative 2 ln x plus 2 plus integrate this one, also we use the u substitution, 2 ln x plus 1, then plus c. So the last answer we simplify this ln function. Let's look at rule number 3. Rule number 3 mentioned that a linear factor ax plus b repeated r times in the denominator corresponds to r partial fraction of the form a1 over ax plus b a2 over ax plus b square until a r over ax plus b to the power of r. Okay, look at this example 11. The integration of 2x over x plus 1 square times x plus 3. We want to integrate this function with respect to dx. So by looking this fraction, it is a proper fraction because the degree of numerator is less than the degree of denominator. First, we look at the denominator part. Okay, by look at this x plus 1 square. Okay, this is a linear factor, but it is repeated twice. And by looking this second denominator, x plus 2, okay, this is a linear factor. So the solution for this function, we want to separate it into partial fraction, is equal to a over x plus 1. It is the linear function, the linear factor, okay, plus b over x plus 1 square. Okay, this is the repeated function, linear function, okay, plus c over x plus 3. So we do a cross multiplication of this function, of this partial fraction, and we get a times x plus 1 times x plus 3 plus b times x plus 3, then plus c times x plus 1 square, divided by this denominator, x plus 1 square times x plus 3. So we can then adequate the numerator. We adequate the numerator part, this numerator part, with this new function. We equate the numerator part by doing this operation to x equal to a times x plus 1 times x plus 3 plus b times x plus 3 plus c times x plus 1 square. Then we expand this equation, and it will get this equation. So we use the substitution x equal to -1 and x equal to -3 based on this denominator part from the original function x plus 1 square times x plus 3 by looking at this numerator part. When x plus 1 equal to 0, therefore x equal to negative 1, and when x plus 3 equal to 0, then x equal to negative 3. So when x equal to negative 1, we substitute into this equation. So we get 2 times negative 1, then equal to a times 0 plus b times 2 plus c times 0. Therefore, b equal to negative 1. Then when x equal to negative 3, we substitute into this equation. So we get 2 times negative 3 equal to a times 0 plus b times 0 plus c times 4. Therefore, c equal to negative 3 over 2. Then, how to find the solution of A? So, we can compare the coefficient of the terms in x2, in x squared, on both sides of the equation. We can compare both sides of x squared. So, the left hand side, we didn't have x squared, so x equal to 0 for the left hand side. And for the right hand side, the x squared, coefficient for x squared is ax squared. And then plus this one cx squared. Okay, that's why a plus c, so equal to 0. Okay, then we find a, so a equal to negative c. So we substitute c, we have found it before this, so a equal to 3 over 2. Then we can substitute the value that we found a, b, and c into this partial fraction. Then they are ready to integrate this function with respect to the x. It is a simple integration. Okay, we can use the u substitution to solve this integration. We can simply use the simple u substitution. We have learned before this in previous topics, which is the u substitution for trigonometric function, or the u substitution for the simple linear or quadratic function. Then we look at rules number 4, the last rule for this partial fraction. Okay, rules number 4 mention that every irreducible quadratic factor ax squared plus bx plus c in the denominator corresponds to a partial fraction of the form ax plus b over ax squared plus bx plus c, where a and b are constant. For example, we have this function. Okay, we want to integrate this function with respect to the x. Okay, it is complicated. So, we have to do a partial fraction to integrate this function. Okay, first we look at this denominator part. Okay, this denominator part, we can factorize the value of x. So we get x times x squared plus 4. First, so we factorize first this function, this cubic function. So we got x over x squared plus 4. So x is the linear factor and the x squared plus 4 is the irreducible quadratic factor in terms of x squared. This quadratic factor. We can't factorize this. So we transform this function into a partial fraction. Okay, the first part of the denominator, we get the partial fraction a over x. The numerator is a constant. For the numerator for this denominator x for linear factor is a constant. Then plus with the numerator for this irreducible quadratic factor, we get is equal to the linear function bx plus 1 plus c. Because the numerator is linear, means that the 1 degree less than the quadratic denominator. We refer the denominator part. Denominator part is the quadratic. Therefore, the numerator part we must follow the linear factor. So equal to this. We equate the numerator as before, and we found that by looking at this numerator part, so 2x squared minus x plus 4, we do this cross multiplication for this partial fraction. So a times x squared plus 4 plus b x plus c times x. We do the cross multiplication. Okay, then we equate the numerator part. So 2x minus x plus 4 equal to a times x squared plus 4 plus bx plus c times x. Okay, by looking at the original function, okay, 2x squared minus x plus 4 over x times x squared plus 4. We know that the x equal to 0. So we let x equal to 0. We substitute into this equation. So we get, for the left hand side, we get 4 equal to 4a plus 0. Therefore, a equal to 1. And then to find the value for b and c, we compare the coefficient of x. So we expand the value for the right hand side, ax squared plus 4a plus bx squared plus cx. We compare with the value for the left hand side. compare the coefficient of x. So the coefficient for x for the left hand side is -1 equal to the coefficient for x for the right hand side is equal to c. So c equal to -1. Then next we want to find the value for b. We compare the coefficient of x squared. So the coefficient for x squared for the left hand side is equal to 2. 2 equal to, for the right hand side, coefficient for x squared is equal to a plus b. Then b equal to 2 minus a. So 2 minus 1 equal to 1. So we get the value for a, b and c. Then we can substitute into this, the value for a, b and c, we can substitute into this partial fraction. Okay, the value for partial fraction is a over x plus b over x squared plus 4 bx plus c. So we substitute. Into this, we get this integration. Integrate 1 over x plus integrate x minus 1 over x squared plus 4 with respect to dx. We split up this fraction into two fractions. This proper fraction into two fractions. And we can simply integrate this function with respect to dx. So the answer will be, so this will be the answer, the final answer. So this is the last example and the reference is from June Aida 2018. Okay, thank you. See you again. Bye.